Hey, 7th graders, today's lesson is 1.4 natural selection. In our last lesson, we learned a lot about histograms. Okay, we kind of developed this idea about how to draw a histogram and what different things that histograms show. And really the main thing that we came out of it is if we're looking at a trait, maybe it's eye color, we can see all the different variations in that eye color, like brown, blue, green, hazel, whatever the case is. And then we can see the distribution of those traits. We can see which individual or how many individuals have more brown eyes versus blue eyes versus whatever the case is. So those are really the two key points that we took out of the last lesson is how to draw a histogram that shows us the variation of traits and the distribution of traits. And today we're really going to dig into that a little bit further and talk about how those histograms might change over a 50-year time period and what might cause that change. So your learning targets for today, I can identify adaptive and non-adaptive traits in a population. Obviously, we're going to learn what adaptive and non-adaptive traits are. And I can predict changes in a population based on existing traits and environmental changes. So again, that really focuses in on, right now versus 50 generations from now. How is that different? Okay, first and foremost, you need to open up your OneNote and add environment, adaptive traits, and non-adaptive traits to your vocab. So environment is everything living and non-living. Remember, we call those biotic or abiotic factors. Biotic are all the living things, plants, animals, bacteria, fungus, all of those things in an environment. Versus abiotic or non-living are all the things like climate, which include temperature of the environment, precipitation in that environment. Could be something as easy as, how thin your air is if you're at higher elevations, your landscape, those kinds of things. Those are all non-living things there. Okay, that surround an organism. An adaptive trait is a trait that makes it more likely that an individual will survive in a specific environment. So if we see a certain environmental change, there's going to be certain traits that make certain organisms a little bit more equipped to survive. So those would be adaptive traits versus non-adaptive traits are traits that would make it less likely that an individual will survive in a specific environment. So for instance, if we're looking at cactuses in a hot desert, if we're looking at their ability to store water, okay, those that have traits that are inclined to store water, those are going to be adaptive traits because they're going to help that cactus live in that hot, dry environment, okay? Versus non-adaptive traits, maybe they're constantly flowering and that uses a lot of water. That would be a non-adaptive trait because that would reduce the amount of water that the cactus could store, making it less likely to survive. Okay, so those are just an example of adaptive and non-adaptive traits for you. Okay, key concepts 2, 3, and 4. The number of individuals with each trait in a population can change over time. So remember that concept is called distribution. And what we'll see in this lesson especially is that over a period of time, distribution will change, and we'll show that using histograms. Okay, key concept 3, over many generations, again, this doesn't just happen overnight. You don't just have a kid, that's a new generation, and poof, we have this whole new change. Okay, individuals with adaptive traits become more common in a population, while individuals with non-adaptive traits become less common. Okay, and then finally, the traits that exist in a population determine which traits can become more common over many generations. So again, these traits don't just appear out of anywhere, they come from some individual. All right, moving on to your warm-up, and remember you guys can take as much time as you need to pause this video and work through each of these sections as you watch. That way you guys aren't just watching the whole video and then coming back and trying to remember what I said. All right, so your warm-up for today. You have 2 histograms below that show the distribution of fur level traits in a population at 2 different points in time. So we've got population A at generation 1 and then 50 generations later. Again, this isn't 50 years, it's 50 generations later. We've got the same population. Okay, so number of ocelotopes or number of individuals on our y-axis, and then we've got our trait variation here on our x-axis. So it looks like we're looking at different variables for fur, so different variation for fur length. Okay, all right, so you guys can examine those 2 histograms and then answer these 2 questions using your draw tool. Do the 2 histograms show the same amount of variation in the population at both generations? So do you see the same amount of variation? Remember, variation is the different traits you see. So, if there's 10 different traits, how many are you actually seeing in that population? Okay, do the two histograms show the same distribution of traits at both generations? So that's going to be the number for each trait. So how many for each trait? Do they show the same distribution? So yes or no. All right, moving on, activity 3. You guys have a little sim link, but first I want to show you guys a couple things first. So here's my sim. If you're using an iPad, make sure you guys choose the correct little, are you using the iPad? Yes. If not, you guys are all selecting no for that, and then you guys should pull up this simulation here. But I just want to show you guys a few things. So for today's simulations, you guys will go up to these 3 little horizontal bars, and I just want to show you guys first fur and temperature A. So I'm going to go ahead and load that. And then what I have is I can mess with my abiotic factors and mess with the environment here. So I can take and I can drag this to very hot. Okay, it was about a medium temperate area there, and then I can see what happens. So if I go hot, and then maybe I can look at my different populations here. Here's my histogram here, and then if I click run, it's really important if you guys don't want to be here forever staring at this that you speed up the time. Okay, and then what I can pull up here is the little histogram. And I can see if that histogram is going to start changing over the generations. So we're at about 10 generations here. And I can click 2 and just see the furs. So you guys can kind of see that those bars are bouncing around. They're not bouncing around a ton now. I didn't change the temperature significantly, okay? It was warm already. I just made it a little bit hotter. But we are still seeing some changes in that histogram. So again, you guys would let this run for about 50 generations will be your key today. Unfortunately, speeding it up times 4 is still not as fast as we would like to see it go. So I'm only on about generation 30 right now. Okay, so you guys again will want to go to generation 50, and just like any of the other sims that we've done recently too, remember if you guys want to see big changes, you need to make big changes. Okay, so again, me heating up this environment by just a little bit wasn't exactly a huge change. So when you guys do this in the sim, it'll tell you guys what to do with your temperature. Make sure you guys make that change as big as possible. All right, so I'm almost at about generation 48, so we're gonna go to 50, and then I'm gonna pause it and show you guys the analyze feature. All right, so if I can go to analyze here, what I see with this gray striped bar is that is our original, and I can kind of go back and drag just like a timeline like we've seen in most of these other analyze. Okay, when I go back to the very beginning, you notice that the blue bars line up with the little striped bars. So that shows us our original. You know, at generation 1, this is what it looked like. Okay, versus the end of that 50 generations, you guys can see the change in the distribution and even a little bit of variation, okay? Here we had some individuals with the number 7 type fur. Number 6, we had a little bit more, and then progressively more for 5, 4, 3, 2, and then 1 had the most. But when I heated that environment up as high as it could go, I'm now looking at saying, all right, we had less distribution for the 1 type fur, way more for the 2 type fur, barely any for 3, barely any for 4, and then it looks like I don't even have any variation for 5, 6, and possibly 7. So I don't even have those fur types anymore after 50 generations. So by heating it up, we no longer see any australopes with those variations. Okay, so that's how you guys are going to be doing this. Obviously, you guys have a little bit different instruction here. So in your guys' sim instruction, it tells you guys to open the sim link. And again, you guys are going to use the same little mode that I went to, where you guys go to fur and temperature A. And then you're going to load that up. You're going to change the temperature of the environment to cold by moving the temperature slider. So here's your temperature slider, here's cold. Okay, you're going to want to take it down to a level 1. Then you're going to go ahead, press run, and observe the population for at least 50 generations. Remember to speed that up so you guys aren't staring at the computer for 17 minutes. And then press analyze and compare the starting and ending histograms. So again, look at the histogram at generation 1 versus the histogram at generation 2. And then here's what you guys are going to do on that is, first of all, you guys need to insert a screenshot the fur trait histogram for population A at 50 generations. So you guys, again, will go in, you'll run that, and then you guys will go to analyze. Let me pause that. And it's going to be that last little chart that you guys have here. So at the highest level over here, it should say 50 generations. You guys will take a screenshot of that. Remember, if you guys are using a Chromebook, you hold down the Control Shift, and then you press the little key above the 6 that has the rectangle with the 2 vertical lines to the right side of it. And then you guys can click and drag, click Capture, should copy it immediately to your clipboard, and then you'll come back into your assignment right here, and you'll do Control Paste or Control V, which will paste your image right there. Okay, if you guys are using something other than a Chromebook, go ahead and search in for your snipping tool and then copy and paste it from there. All right, moving on into your activity 3. Why do you think the distribution of fur traits changed over time? So make a prediction. You know, when we made it colder in that environment, what do you guys think caused that distribution to change? And which trait became more common over time? So that would be an adaptive trait. So which one of those was an adaptive trait that made that individual survive a little bit more easy, therefore becoming a little bit more common? So why do you think this happened? All right, activity 4 is modeling. So we just did a little example where you guys made this environment colder, okay? And now we're gonna model kind of what that looks like, and this is gonna help us make a prediction. Just showing you guys this model is gonna help us predict our next model, which we will then test out in the sim. So let's just take a look at this model. This is gonna be your guys' template for how you guys are modeling things. You guys can notice that the goal up here says to show how and why population A changed after the environment was changed from warm to cold. So again, this is the change that you guys just made in the simulation. So you guys can see what the starting histogram looked like, and this is very similar to what you guys started with as well. Okay, it's also the same as what you guys saw in the warm-up. Okay, we have that same little distribution there. It doesn't look as large, but that's just because your scale's off a little bit. So you guys can still see that it's the same distribution, that increasing from 7 up to 1. Okay, so our environment changed from warm to cold, so then 50 generations, our environment later was cold. So you guys can see starting population and population after 50 generations. And then down here we have some labels that we're going to make on here. So trait labels, these would be our adaptive traits. They're more likely to survive. And these would be our less likely to survive. These S- traits are our non-adaptive traits. So how you guys would model this is you guys would obviously use your draw tool. And you guys can just do a plus or a minus too, that's a-okay. But if we look at this, and you guys saw this happen, we saw that those with the lower fur variations were less likely to survive. So what you might put on here is maybe a minus, or excuse me, less likely to survive, a minus, a minus, a minus, versus like 7 through 4 or 5 would be a plus. So we saw those being more likely to survive. They must have a little bit longer fur. If you guys watch them too, when you guys cool them down in this environment, you guys can zoom in and you guys can click on an individual. Oh, they're going way too fast for me to click on right now. Hold on. You guys can click on an individual, and then when you change their temperature to cold, you guys can watch them shiver. So let me show you what this would look like here. Let's find one of these balder guys that have a little less fur. So you guys can see them. You can click on them, and you can see them shivering. Okay, they're still able to mate at this time, but watch. Oh, he just died. He died from starvation. So you watch this guy right here. He's shivering. So he's obviously cold. You guys can also see his fur is at a 1. So he has that lower fur. Okay, so you guys can kind of mark those up as either plus or minus based on whether you guys think they're going to survive. Maybe you guys put a minus, I don't know, a plus here. We'll probably see some of those survive, maybe not as well. Okay, and then you guys could fill in and say, all right, if I think 7, 6, and 5 are more likely to survive, then maybe this is going to be my higher distribution. And maybe this kind of just reverses itself. 6 is going to be here. Your guys' traits might look a little bit different, and maybe we still have some of these 3 and 2 surviving, and maybe even a little bit of 1. Okay, so you guys can kind of mark on there what you guys think your distribution of your histogram might look like after 50 years. So let's go check out and see what an actual model of this might look like. And again, your guys' idea might be a little bit different. This is just a prediction. So we can kind of see something very similar where they marked our 1, 2, and 3 as S minus, and our 5, 6, 7 as plus. And then you guys can see we definitely have more surviving of that 5, 6, 7, even a little bit of 4. But 1, 2, and 3 they put not surviving. And that's okay that our little idea was not the same as theirs. That's totally okay. I predicted that maybe a little bit more would survive in those 1, 2, and 3, but I was wrong. Okay, and that's why we're going to use the sim to test it out. So let's go ahead and use this model to make a prediction for our next environmental change. Okay, so predicting fur traits in a cooling environment. Use the modeling tool, fur and temperature population B. So we're using a new modeling tool to show your prediction about how the distribution of traits in population B will change as a result of the environment becoming cold. So goal, predict how and why population B will change after the environment changes from warm to cold. Analyze histogram 1 and label the histogram with any trait labels that apply, so that's the little plus and minuses. And then predict histogram 2 by shading in the bars for different trait levels. You can use trait labels more than once and you do not have to use them all. So let's take a look at this. All right, so we see predict how and why population B will change after the environment changes from warm to cold. So we can see that obviously population B has a little bit different variation in distribution than what we saw up here with population A, right? We saw a lot more variation and a lot different distribution than we see now, okay? We have a very low variation here. We really only have 2 types of fur. So what you guys are gonna do then is you're gonna use the plus and minuses down here, and you guys are going to predict either a plus or a minus above each bar to think how, all right, how's this trait going to do based on what you guys just learned. Remember, we're going from warm to cold, and then our environment 50 generations later will be cold. Okay, so use these little plus and minus signs above each of these 2 bars to tell me how you guys think those traits will do in a colder environment. Okay, will they be adaptive or non-adaptive? Then with that being said, you guys will go ahead and redraw your bars here. So if you guys think they're going to be more successful, obviously you guys would maybe use your highlighter and draw a bigger bar. Okay, or if you think they're going to be lower, then maybe you draw a lower bar. Whatever the case is, that's up to you guys to predict. Again, this is a prediction. We're going to test this out in the sim, so it's okay if you guys are wrong. It'll give you guys something to go back for and look through. Okay, so go ahead, fill out your guys' chart labels for these 2 columns here, and then fill out what your histogram will look like here. And then let's go ahead and move on to the sim and test that. Okay, so test your predictions about how the distribution of fur traits in Australope population B will change when the environment becomes colder over time. So open your sim, do fur and temperature B. So again, I'm going to go these 3 horizontal bars, fur and temperature B, load that up. Okay, and then change the temperature to cold, again, level 1 by moving the slider. Press run and observe the population for at least 50 generations. Same there, make sure you guys speed it up so it goes a little bit quicker. Zoom into the environment and observe several individuals with different traits. So you guys can, as the time is ticking over those 50 generations, zoom in and just watch what some of those Australopes are doing. Okay. Use the traits histogram window to observe the distribution of the population. So again, that's in the bottom left-hand corner of the sim. And then when you're all done with those 50 generations, press pause and then hit analyze. Just like with the last sim, you guys need to take a screenshot at the end of that 50-year time period that shows you guys what your histogram looks like then and then what it looked like 50 years ago. So remember what it looked like originally was those gray bars with the horizontal dashes or the diagonal dashes. Okay, so take a screenshot there and then answer this question. Did population B change in the way you predicted in the modeling tool? So you guys made this prediction right here. Did you guys see it actually change the same way? Does your histogram look the same? Okay, all right, once you've answered that question, let's move on to our final activity, which is activity 6, reading. You guys have some articles to read, and I'm going to talk about a little extra credit opportunity for you as well. So go ahead and open the Wildlife in the Woods article set. You guys can right-click it, open it up, and then you're going to read the intro, read the article on the garter snakes, and then answer the questions. Choose one other organism to read about and answer those questions as well. So let's go ahead and take a look at what those articles look like. I'll read the introduction for you. Parts of Oregon are covered with forests. Those forests are home to all kinds of organisms. The forests of Oregon are full of organisms, animals, and plants, big and small, furry and feathered and scaly. All of these organisms have traits that make them well suited to living in the environment of Oregon. If they weren't well suited, they probably wouldn't survive there. To learn about organisms of the Oregon forest, read one or more of the chapters that follow. Okay, so you guys will go up to your little table of contents up here, and you guys are going to choose the common garter snake to read first. Okay, I don't know about you guys, but the look of that picture gives me the heebie-jeebies. I've never been a snake person. Okay, so go ahead and read each one's about 3 paragraphs long, so they're pretty small, and you guys get some really fun facts there. Like, for instance, this last little one is, you know, reptiles lay eggs, but garter snakes give live birth, which is really crazy to me. I can't imagine looking at a garter snake as it's giving birth to 40 baby, like, ugh. Sorry, can't handle it, not my jam, okay? All right, so read the garter snake, and then you guys will answer these 2 questions. What part of the environment might make an individual more or less likely to survive? So think specifically about those garter snakes in this Oregon environment. So what are good things about that environment for the snake, and what are some bad things about the environment for the snake? Remember, environment can be both living and non-living. Okay, which trait does the common garter snake have that might be adaptive for the environment where it lives? Okay, so which trait does the common garter snake have that might be adaptive for the environment where it lives? Okay, so talk about just some things you learned about that garter snake. All right, then you guys are going to choose one other article to read. You can either choose the harvest mouse, the screech owl, the black bear, the Douglas fir tree, and then the holly, which is a type of little berry tree there. And you're going to read that one of those, circle which one you guys chose to read, and then answer those 2 questions again. What parts of the environment, living or non-living, might make an individual more or less likely to survive? So what are some good things about the environment? What are some bad things? And then which traits does this one's going to say your organism. Which traits does the organism have that might be adaptive for the environment where it lives? Okay, so that's your guys' end of your lesson. However, if you want an extra credit opportunity, you guys can choose a 3rd article to read. Again, not the garter snake, not whatever one you just read, but choose, again, one of those, circle, and answer those same questions on as before. Okay, and then go ahead, do your wrap up. Do you have any questions? Circle yes or no. If yes, type them below. If no, go ahead and do 4, 3, 2, 1. How do you think you did? And you guys are all done. You can go ahead and hand it in, and I hope you're having a great day. Bye.